Right now in the world, we see a lot of conflicts. And I feel like when we consider the really big global challenges we tackle in science and the human endeavor involved, we are able to see above all those differences because we all have the same curiosity and the same questions. I'm Claudia Lagos. I'm an astrophysicist at the International Centre for Radio Astronomy Research in the University of Western Australia. What I do kind of on a day-to-day basis is to try to understand how galaxies form and evolve, basically using computer simulations to try to get to that understanding. The way we do that is by saying, okay, these are the laws of physics as we know them. So how can these laws give rise to the types of galaxies that we observe, like our own Milky Way, for example? So we feed everything we know into a computer to create simulations that we can then compare to observations. Does it look anything like what we actually observe? Our observations are extremely rich. We see galaxies come in all sorts of shapes and colors, and some are extremely big, some are very small. We are at a point in the simulations where we're starting to get some kind of diversity that looks like real galaxies. So once you get to that point, we can start questioning, what do we need to do now to answer some questions that are still open? What kind of observations we would need to do to resolve that type of question? So, for example, I've worked a lot on supermassive black holes. So we know pretty much all galaxies that we observe have a supermassive black hole in their center. And although it's a tiny scale compared to the whole galaxy, we found that it can actually have a huge impact on the fate of that galaxy. We also look at how stars form throughout the universe. So we know that in the past, the universe was a lot more active in forming stars than it is now. And similarly, we can observe the gas content of galaxies. And there was a big problem there because we saw that the two were evolving very differently. But we know that stars form from gas. So it was, this question of why are these things not resembling each other? Turns out you need to trace the quite dense and very cold molecular gas. And the simulations predicted very nicely that, including my own simulations early on, that if you were to trace all that cold and dense gas, then you could see star formation much better. And that was actually observed years later. So simulations can really help understand star and galaxy formation.
And this is not strong enough, basically, but they're still running down the road.
I am very passionate about producing open source code that is free to use for the whole community. All researchers can benefit and everyone can see what's happening inside. And that's why we produced our semi-analytic model of galaxy formation called SHARC. I feel extremely privileged, but also very proud to be recognized for work, that sometimes you're on your desk working the whole day. You never know if not someone notices, It's beautiful to see that acknowledgement of our scientific interest, but also of our tools that can be used by the community as a whole.